Imagine lining up Google's official command line interface, backed by the resources of a global tech leader, against a custom CLI built by a solo developer. In practice, the solo developer's terminal agent outpaces the official tool across nearly every performance metric. This gap exists because standard software relies on heavy, layered architectures that create significant computational drag. Three specific bottlenecks bog down processing power: traditional JSON parsing, expensive cloud-based security rules, and on-the-fly runtime evaluation. Outperforming a corporate giant requires a total departure from standard methods. Success depends on rethinking how data executes at the foundational architectural level. Developer Elton Bonin engineered a solution to this problem, creating a framework called the BJSON ecosystem. BJSON is a mathematically strict data architecture designed specifically to run efficiently on edge devices like mobile Termux environments. This single framework serves as the structural mechanism used to dismantle all three pillars of corporate software lag. We start with the first major bottleneck: how data is mapped and parsed. Standard JSON structure is inefficient. It dynamically parses redundant string keys for every single record, which inflates file sizes and consumes CPU cycles just to identify a single value. Elton's solution involves decoupling the structural schema from the raw tuple arrays. This introduces the core concept of O1 positional integrity. Instead of forcing the system to read string keys repeatedly, it bypasses string lookups entirely and accesses data via direct, fixed numerical index offsets. Eliminating redundant key overhead reduces storage by up to 50%, allowing flat file databases to scale without degrading performance. The second bottleneck involves securing data, specifically when integrating AI agents. Standard architectures rely on cloud platforms like Firebase to compute type checks, generating latency and driving up transit costs for every payload sent over the network. If an AI hallucinates a new property that isn't defined in the database schema, it can silently poison the cloud state. Elton's countermeasure shifts the computational validation load entirely to the device, using a system called the BJSON gauntlet. The gauntlet acts as a strict local deterministic validator. If a data payload is mismatched, the gauntlet instantly breaks the build locally, long before a network request is ever initiated. Shifting security away from reactive cloud debugging and relying on proactive local prevention stops invalid AI writes and protects cloud resources. The final bottleneck for mobile environments lies in runtime execution. Google's official CLI relies on spawning subshells and calling external tools like jQuery to parse data on the fly. On resource-constrained devices, forcing the CPU to continuously generate these subshells causes severe latency spikes. Elton solved the execution layer problem through ahead-of-time, or AOT, compilation. The compiler parses the BJSON structures just once, baking all hooks, states, and choices directly into literal native bash associative arrays. By the time the script executes, it runs with absolute zero subshell latency. Baking out latency before the program even runs is the definitive strike that grants the NewAgent CLI its superior speed. Observing these two distinct software architectures reveals a stark contrast in philosophy. NewAgent's performance advantages stem from operating with uncompromising mathematical strictness. Shedding computational deadweight through constant time indexing, local edge-based gauntlets, and ahead-of-time compilation results in a system that remains responsive under extreme loads. Technical optimization isn't achieved by adding cloud compute power to inefficient architecture. A single developer armed with absolute structural discipline can redefine the limits of performance and out-engineer the world's largest tech giants.